Good morning to all of you. In previous sessions, we have seen as well as discussed basic realization structures for IR systems, where we have seen direct form 1, direct form 2 realization, cascade and parallel realization. Then we have seen the transposed form realization, and finally, we have seen the ladder structure realization. So, in today's session, we'll be discussing realization structures for FIR system, that is finite impulse response system. So it comprises the input output relationship in terms of only present and past input samples, right? It doesn't have the feedback output in its input output relationship. Therefore, these system FIR systems are also called as non-recursive system. Okay, because in the recursive system, feedback output is there. So in today's session, we'll be discussing direct form and cascade realizations for a fire system. So the basic structures for finite impulse response systems can be obtained by using the transfer function or the system function. So the system function of a fire system whose realization take the form of a non-recursive computational algorithm may be written as capital H of Z is equals to summation n is equals to 0 to m minus 1 h of n into z to the power minus n. Okay, so whatever system function that we have discussed for IR system, it comprises numerator terms and denominator terms, but in case of the FIR systems, it will have only the numerator terms. Okay, it doesn't have the denominator terms, right? So in case of IR system, we have written this system function h of z as the form of in the form of numerator and denominator, and we have written it as y of z upon x of z, and it has been written as summation k is equals to 0 to m minus 1 bk into z to the power minus k whole upon 1 minus summation k is equals to 1 to n minus 1 ak into z to the power minus k, right? So it has the terms corresponding to input in numerator, while terms corresponding to previous outputs or past outputs in denominator. So this is for what IR systems that we have seen. So this transfer function is utilized for the realization purpose of IR system. So where this system is also called as pole zero system, as well as it is a recursive system because past outputs are there. But in case of FIR system, the system function has the form which comprises only the present or maybe past input samples. Okay, so it will have only pole terms, or it can be represented in generalized form as this equation, right? So if you compare this equation with this numerator equation, so you will find it similar, only the summation variable has been used as n in this case. Okay, while in place of this coefficient, that is bk coefficient, there is h of n, right? So this is non-recursive system, right? So let's see one example for obtaining the cascade and direct form realization of realizations of FIR system. Okay, so here you can see in this example the system function or transfer function of FIR system is described as h of z. Okay, I will write here the given transfer function or system function is h of z is equals to bracket 1 minus 1 by 4 z inverse plus 3 by 8 z to the power minus 2, another bracket 1 minus 1 by 8 z inverse minus 1 by 2 z to the power minus 2. Okay, so here as it is specified in the example, you have to obtain direct form and cascade form realizations. Okay, for this given FIR system described by this transfer function. Okay, so initially we'll try to obtain the direct form realization. Okay, so here for direct form realization will just modify this transfer function. We'll expand the transfer function h of z by multiplying these two brackets. Okay, so if I multiply this, so I will get initially 1 will get multiplied with the complete bracket, so it will be 1 minus 1 by 8 z inverse minus 1 by 2 z to the power minus 2, then this will be minus 1 by 4 z inverse minus minus plus 1 by 32 z to the power minus 2 plus 1 by 8 z to the power minus 3 plus 3 by 8 z to the power minus 2 minus 3 by 64 z to the power minus 3 minus 3 by 16 z to the power minus 4. Okay, so after subtraction and addition, that is minus 1 minus this 1 by 8 z inverse, so minus 1 by 4 z inverse is there, right? So if you add this, so you will get minus 3 by 8 z inverse. Okay, similarly minus 1 by 2 z to the power minus 2 plus 1 by 32 z to the power minus 2, then there is 3 by 8 z to the power minus 2, so its addition will be minus 3 by 32 z to the power minus 2. Okay, similarly this we have added this 1 by 8 z inverse, then minus 1 by 4 z inverse is minus 3 by 8 z inverse, then this 1 by 8 z to the power minus 3 minus 3 by 64 z to the power minus 3, so it will be plus 5 by 64 z to the power minus 3, and then minus 3 by 16 z to the power minus 4. Okay, so I'll just rewrite this equation on next slide. So now we have this h of z is equals to, it is the 1 minus 3 by 8 z inverse then minus 3 by 32 z to the power minus 2 plus 5 by 64 z to the power minus 3 then minus 3 by 16 z to the power minus 4. Okay. So here you can see that this h of z is in this form, right? Or it is in this simply the numerator form, right? So from this equation you can directly obtain the direct form realization. The corresponding direct form realization is shown in following figure. Okay, so here again you can indicate input x of n or x of z, right? So first term is 1, so this one is added here, so it is added with this delay multiplied by minus 3 by it. Okay, so you will need one z inverse here and one constant multiplier you will use here, that is it will be minus 3 by 8, right? Similarly, next one is again another delay element, so here you have z inverse, then here output you will get z to the power minus 2, then again it will get multiplied with this constant, that is minus 3 by 32, then again these terms will get added here, right? Similarly, third delay element, z inverse, again a constant multiplier will be required, that is 5 by 64, these terms will get added. Finally, this last delay element, okay, there is z inverse again multiplied with a constant, that is minus 3 by 16, then this will get added here. Okay, and this output is nothing but y of n or y of z. Okay, so this is how this direct form realization of given transfer function or a fire system can be represented. Okay, so this figure indicates direct form realization of given FIR system, right? So if you observe this, we have drawn this in horizontal form. Okay, you can also resemble this diagram with the direct form 1 or direct form 2 realizations that we have obtained for IR system, okay, in the previous session, where we have drawn it in vertical form, right? So the structure can also be drawn in vertical manner, right? But for representing in compact way, we are drawn it in horizontal form, or it can be drawn in vertical manner, right? Where you will be applying x of n or x of z, then input here 1 will be added, then you will be using delay element here, then delay element will be again added with this, again another delay element will be there, constant multiplier minus 3 by it will be there. Okay, likewise you can obtain it, correct? Just for your convenience, I will just draw initial this x of n or x of z is there, right? So here you can indicate this one first term, then there is delay element, right? then this is multiplied with this minus 3 by 8. Here you can add it, right? Another adder you will need it here, correct? Then similarly another delay element, again a constant, but minus 3 by 32, another adder, again here you will be adding. So likewise you can continue with this one. So this can be drawn in vertical form also. Okay, here you can indicate its output as y of n or y of z. Okay, but here we have drawn it in horizontal form, right? Okay, so only I have drawn here two stages, right? That is up to this particular point, up to these three terms. Remaining two terms again can be drawn below this. Okay, for uh, the solution purpose you can draw this particular diagram. Okay, another realization that we have to obtain here is for uh, in the cascade form. Okay, so let's see the cascade realization of the given transfer. So cascade realization. So for cascade realization we'll use this h of z as it is, right? Because it is already given in the two multiplication form, because for cascade realization we'll be connecting system in series, right? So we'll require terms in multiplication form. Okay, so we'll use this transfer function as it is. Okay, so it is in first bracket we have 1 minus 1 by 4z inverse, right? Then plus 3 by 8 z to the power minus 2. So whatever equation is given in the example we are using this equation as it is. Okay, in another bracket 1 minus 1 by 8 z inverse. Last term is minus 1 by 2 z to the power minus 2. Okay, so we are using this given equation as it is. So the corresponding cascade realization is shown in following figure. Okay, so here you can attach two systems with each other, right? So here again you can horizontally draw this realization or vertically draw this realization. So let's draw it x of n or x of z will be input. So first term is 1, so this one is get added here, then z inverse is required, one delay limit is required, which is multiplied with constant minus 1 by 4, right? Another adder is needed here. You will need one more delay element, in this case z inverse, then again it is multiplied with constant 3 by 8, then it will be added here, right? Okay, so this is how you can represent this first bracket. Okay, then in cascade you will be connecting it with this system, another system, right? So again here you will need delay element, this one will be indicated here, right? This will be added here, output will be y of n or y of z, then again constant multiplier, it will be multiplying minus 1 by 8, this will be added here, then again it will be going into the system, then again delay element will be needed, right? Again it will be added this multiplied with this minus 1 by 2, and this will be added here. Okay, so this is nothing but the cascade form realization. Realization of given FIR system. Okay, so this is how you can obtain the direct form and cascade realizations of FIR system. Okay, in case of IR system, we have seen direct form 1 and direct form 2 realization, but in case of FIR system, there will be only direct form realization, because in case of IR system, as it is recursive system, it has numerator and denominator in transfer function, right? So therefore there are two direct form realizations in case of IR system, that is direct form 1 and direct form 2 realization. But in case of FIR system, there is only numerator term, so therefore there is only one direct form realization structure. Okay, so in next session we'll be discussing lattice structure realization for a FIR system, that is finite impulse response system, and we'll also see how to obtain direct form filter coefficients or discrete time system coefficients from the lattice structure coefficient. Okay, so thank you for joining this session.